If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only two confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger. Okay, watch your step now. Millions of gallons of hot magma are gathering in one flow and rising thousands of miles to the surface of our planet. A massive fracture in a tectonic plate shakes the ground and fills the air with a loud hum. Fire, gases, lava erupt from the dark, unexplored depths of Earth's crust. A planetary-scale catastrophe has just happened, and no one's noticed it. Now imagine you're having fun on a luxury yacht somewhere in the southwestern Pacific Ocean. drinking cocktails and sunbathing. At this moment, one of the most powerful volcanic eruptions in the planet's history is happening right below you. But you don't feel anything. You don't even drop your glass. Yeah, you can hear a strange sound coming from the ocean depths. You see foaming water and pieces of pumice floating up to the surface. But it doesn't bother you much. So how did it happen that we missed such a powerful eruption in 2012? Why did scientists find out about it only a few years later? The answer is simple: water. An eruption of an ordinary volcano is a huge disaster. There are incandescent liquid metals and molten rock containing almost the entire periodic table inside our planet. All of this soup is called magma, and it's constantly boiling inside the subsoil of our world. This hot substance is lighter than the surrounding crust, so it always rises. Fortunately, the planet's surface is strong enough and doesn't allow magma to splash out. But sometimes this protection fails. The upper part of Earth is covered with connected parts, tectonic plates. These plates collide with each other and then move apart. Imagine a big moving mosaic puzzle where all its parts are tectonic plates. And when a small part of this puzzle gets separated from another, magma immediately comes up. These unstable fault sites with leaking magma are called volcanoes. And when they erupt, it gets hot. Lava flows out of the vent and burns all the vegetation around. This is accompanied by earthquakes and thick black smoke. If a volcano spits out magma too high, it falls back to the surface in the form of fire rain. But the worst thing here is ash. It's not that ash that's left in your grill after a good barbecue, no. Volcanic ash consists of solid particles harmful to any organism. These particles are not burnt wood, but various chemical elements. Volcanic ash is sharp, dense, and tangible. It can block sunlight, cover and destroy all plants, settle in your lungs. If you get too close to an erupting volcano, well, you better have a fireproof suit, oxygen tanks, a gas mask, and an underground shelter. Then you might survive, but there's no guarantee. At the same time, if an eruption occurs underwater, you don't need to worry about it. Of course, if you're not a marine biologist studying coral reefs nearby, or if you don't travel past that area in a submarine. In that case, boy, you're in trouble. When an underwater volcano erupts, this shakes a colossal area, heats the water, destroys the seabed. But almost nothing happens at the surface. The enormous pressure of millions of gallons of water suppresses the destructive power of the volcano. Molten rocks shooting out of Earth's crust get pressed against the seabed. Yeah, a submarine swimming by would be thrown off course and might collide with solidified lava. Fortunately, no such cases have ever been recorded, but it can easily become a reality because underwater eruptions happen pretty often. More than 70% of all volcanic activity occurs underwater, and almost no one notices it. In most cases, these volcanoes immediately fall asleep after they erupt and never wake up again. But in 2012, something happened, and scientists couldn't ignore it. Big pieces of pumice, the size of a van, began floating up in the southeastern Pacific Ocean. These rocks covered about 154 square miles. There were thousands of them. They looked like a group of unknown floating mini-islands. Volcanic stones were scattered in the ocean over the area twice as large as New Zealand. Scientists determined the full scale of the disaster with the help of deep-sea sonar devices. They studied the seabed at a depth of 4,000 feet for a long time and found 14 craters from which magma had flowed during the eruption. The seabed was covered with frozen lava flows and tons of ash. The researchers found that more than a third of the erupted volcanic material surfaced and was scattered all over the place. The rest remained at the bottom. This wiped out all marine life in the area. It seemed that this eruption was one of the largest in the entire history of observations. But in 2019, researchers discovered something even more significant. That was an underwater volcano 3 times higher than the Eiffel Tower. According to scientists' calculations, it ejected between 30 and 1,000 times more molten rock than the previous volcano. This monster had been feeding from the world's deepest magma reservoir we know about. Seismic activity here was so devastating that it destroyed everything around. Fortunately, not for long. After any eruption, life reappears like a phoenix rises from the ashes. And it's not just a figure of speech. Volcanic ash and lava around the volcano contain many useful mineral elements. All of them nourish the soil and help microorganisms develop on land and in the water. For this reason, there's usually so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form islands. This is a long process that ends with the appearance of a massive piece of land above the water surface. To understand how this happens, you need to go back millions of years. So, let's go! See this underwater volcano? There are sea dinosaurs, giant sharks, and ancient fish swimming around. Now, the seabed starts shaking. The volcano releases tons of magma and ash. The water pressure immediately pushes all this stuff back to the bottom. The eruption can continue for a long time. The released magma raises the seabed. After hundreds, maybe 1,000 years, a new eruption begins. New magma flows create a new layer above the previous one. Over millions of years, layer by layer, the volcano is growing. It's slowly rising, thanks to constant eruptions. Of course, with time, some volcanoes go dormant, but this one continues to erupt. And then, one day, the volcanic rock reaches the surface and an island emerges. After many more years, the volcano can fall asleep. After this, life is likely to appear on the island. Grass, flowers, trees, animals. The area that was once ruined seabed is swarming with life now. Volcanic islands have unique ecosystems because they develop separately from all the continents. Observing such islands helps scientists understand how life on Earth evolves. New species of birds, animals, insects can live on these chunks of land. Hundreds of islands around the world appeared thanks to eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, Iceland. Many of them are inhabited by people who build villages and towns there. There were cases when a volcano erupted when people literally lived on top of it. That's what happened on the small island of Aogashima, located to the south of Tokyo. People built a beautiful town right in the crater of an active volcano. And in May 1785, an eruption began. Nobody expected this to happen. At some point, thousands of birds rose in the air and flew away from the island. Then the ground began to shake. A heavy, low sound shook the air. Thick smoke appeared above the top of the green volcano. The crater started spitting dirt, huge rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People somehow managed to evacuate. Then, finally, the volcano calmed down. After that, a long process of recovery started. The inhabitants of the town rebuilt houses, roads, infrastructure. More than 200 years have passed since that moment, and during this time, the volcano never woke up. And despite the risk of a new eruption, people continue living there. The population is growing. Many people from other cities and countries come to live there. The main reason everyone loves this place is that it looks like a paradise. Nobody wants to leave the island. There are thermal springs where you can bathe, dense jungle with many beautiful animals and trees. The soil is rich, and you can grow tasty fruit and vegetables there. The water near the coast is swarming with fish. Every day, you can enjoy the incredible landscapes of the island. Seismological services constantly monitor the situation and watch the volcano's activity, listening for a rumble that may someday come again. In 2018, the most powerful underwater earthquake occurred between East Africa and Madagascar. There was a deep rift between the Earth's crust and the mantle. Hundreds of thousands of tons of magma came out on the surface of the ocean floor. After that, a huge underwater volcano with a height of 2,700 feet was formed near the coast of Madagascar. This is almost twice the height of the Empire State Building, and all this is hidden under the water. French scientists studied this place since it had regular seismic activity. When the geologists went on an expedition to the coast of Madagascar, they discovered this giant underwater rock, which was not here until recently. With the help of geological equipment, they discovered the earthquake happened deeper than usual, below the Earth's crust. Geologists created a special observatory to monitor the situation at this site in real time. Between February and May 2019, they recorded about 17,000 seismic activities below the ocean floor. Scientists had never recorded such deep earthquakes. This suggests that there are reservoirs and drainage systems inside our planet through which magma flows. It's like the veins and vessels of a living organism. The volume of lava the volcano spews at this place can be compared with the volcanic eruptions in the hottest spots of Earth. Perhaps this is one of the most catastrophic, but at the same time, beautiful events in nature over the past few years. To understand what can be beautiful about this, let's first figure out what an underwater volcano is and how it works. Inside our planet, there are incandescent liquid metals and molten rocks containing almost all the chemical elements from the periodic table. All this hot substance is called magma, which constantly flows in the planet's bowels. Anyway, magma is lighter than the surrounding Earth's crust, so it always tries to break out upwards. Fortunately, the surface of our planet is strong enough and doesn't allow magma to splash out. But sometimes it happens, and here's why. The Earth's crust consists of many solid parts, tectonic plates. These plates collide with each other because of movement. Imagine a massive picture of puzzles. Each detail of this puzzle is a tectonic plate, and they all are constantly moving. Sometimes one puzzle gets unhooked from another. When this happens, magma immediately spills out of the resulting gap. And these places of faults with flowing magma we call volcanoes. When such a volcano erupts, a new geology begins. A splash of magma shakes the ocean floor. Lava and ash erupt from the inside of our planet. It causes a release of destructive energy of incredible power. But thanks to the water, such a catastrophe can go unnoticed. More than 70% of the seismic activity associated with volcanoes occurs underwater, and almost no one notices it. But inside the water, there's a total mess. Lava heats the water and destroys the seabed. The ocean in this area boils, and large air bubbles rise up. But the enormous pressure of hundreds of millions of gallons of water suppresses the volcano's destructive power. Molten rocks of the Earth's crust are pressed against the seabed. The ocean blocks the consequences of the disaster, but sometimes the eruption gets to the surface. Such a case occurred in 2012. Vast pieces of pumice, the size of a van, began to float up in the southeastern Pacific Ocean. There were hundreds, even thousands of them. It was more like a group of unknown islands. Volcanic rocks scattered in the ocean over an area twice as large as New Zealand. Scientists used deep-sea sonar apparatus on the remote control to determine the full scale of the disaster. They studied the seabed for a long time and found 14 craters that released lava. The researchers saw that more than a third of the erupted volcanic material surfaced and scattered throughout the ocean. The rest was scattered along the bottom. It destroyed all marine life in the area. However, after the eruption of volcanoes, life is reborn like a phoenix from the ashes. Volcanic ash, lava, and soil around the volcano contain many useful elements and minerals. They nourish the soil and promote the development of microorganisms not only on land but also in water. That's why there's so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form natural islands. This is a long process, resulting from which a large piece of land comes out of the water. When magma goes out, the water immediately presses it to the seabed. The eruption can go on for a long time. The released magma raises the level of the seabed. After another 100, maybe 1,000 years, a new eruption begins. New magma flows lay a new layer on the surface of the previous one. Over millions of years, layer by layer, the volcano has been growing. It's slowly rising up because of constant eruptions. Some volcanoes may go out forever, and some continue to erupt. And then, one day, the level of volcanic rock reaches the surface in the form of a huge island. After many more years, the volcano may go out, and then life appears on the formed island. The destroyed seabed area is filled with animals, trees, flowers, and plants. These volcanic islands have unique ecosystems because they develop separately from all continents. Observing such islands helps scientists understand how life on Earth was born. There are hundreds of islands around the world that have appeared because of eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, and Iceland. Many of them are inhabited by people. They build villages and small towns there. The ground on such islands is fertile. Fruits and vegetables grow there. The water is filled with fish. Such places may seem like paradise, but at the same time, it's dangerous to live there because the volcano may wake up. One of the most famous eruptions occurred on the island of Ogashima, south of Tokyo. People built a beautiful city right in the crater of an active volcano, and in May 1785, the eruption began. No one expected this to happen. At some point, thousands of birds rose and flew away from the island, and then the ground began to shake. A heavy, low sound came from beneath the underground depths. Thick smoke escaped from the top of the green volcano. The mountain threw dirt, large rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People managed to evacuate, and then there was a long recovery. Locals rebuilt the houses and brought the city back. Almost 250 years have passed since that moment, and during this time, the volcano has never woken up. Despite the risk of a new eruption, people continue to live there. The population is growing since this place resembles paradise, and no one wants to leave it. There are thermal springs, dense jungles with rich soil, and many fish. Meteorological and seismological services constantly monitor the volcano's activity. Movements and fractures of tectonic plates create another natural disaster: destructive tsunamis. Unlike volcanoes, huge waves are formed when seismic activity causes the crust to move vertically, up or down. When this happens, water pressure shifts on the ocean floor, which releases energy. This energy pushes the water and creates a tsunami. By the same principle, you form a small wave when you throw a stone into the water. First, a small tsunami appears. Then it picks up speed and increases in size. Its height can reach the level of a 5-story building. It's heading for the coast and accelerating to 500 miles per hour. This is almost twice as fast as a Formula One race car. Millions of gallons of water, weighing thousands of tons, are getting closer. And now the wave reaches the shore and demolishes everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. Such tsunamis are a frequent occurrence on the coast of Japan. People have built massive shields near the land to stop the waves before they hit the shore. Still, in spite of all preparedness, somehow, nature always prevails. Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring axial seamount, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So, here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like Axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes axial seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean-bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, Axial Seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned Axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, Axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when Axial decides to pop. But hold on, Axial Seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but Axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, Axial's location is like prime real estate for geological fireworks. It sits right where two major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where two tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives Axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial Summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler, well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where similar vents might exist beneath their frozen surfaces. When Axial erupts, it's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial's eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding Axial's patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live-stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front-row seat to a natural fireworks display, thousands of feet beneath the waves. The livestream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking Axial's instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in Axial's eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when Axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale. On January 14, 2022, residents of Anchorage, Alaska heard a series of loud bangs. They didn't stop for a half an hour. As they found later, the source of the bangs was almost 6,000 miles away, in the Tongan archipelago in the southern Pacific Ocean. The Hunga Tonga underwater volcano abruptly woke up from its sound sleep. It last erupted at the end of December 2021 after several years of inactivity. Hunga Tonga sent a large plume of ash into the stratosphere that was seen in the capital city of Tonga, 43 miles away from the volcano. In the following days, it was emitting steam and gas to the height of 7 miles. Plus, it was letting out ash that accumulated next to it and even made the island on which it was standing increase in size. Then, it went back to sleep, and the officials even announced it was dormant. But just a couple of weeks later, it woke up again with a crazy force. It sent ash clouds 12 miles into the atmosphere. It blocked the sun in some places and rained down from the sky. The sound waves from the eruption traveled around the planet several times. People in Fiji heard a sound that reminded them of thunder. Some booms even reached Canada. Shockwaves went around the Earth 4 times in Japan and Utah, and at least twice in Massachusetts. The eruption caused tens of thousands of lightning flashes. It also triggered a mega tsunami hundreds of feet high. It caused damage to buildings and infrastructure, such as underwater cables. The extreme waves traveled all the way to the California coast, and there was an unusually high tide along the Pacific coast of Canada. Scientists studied seismic data to understand what caused such a massive eruption. Their research models showed that there was a big blast, likely because gas got trapped in rocks, like how a pressure cooker works when it's overcooked. This blast released a huge amount of energy, as much as 5 of the biggest underground nuclear tests. It all happened under a shallow part of the sea, where gas-filled rock was trapped. Now, normally when a volcano erupts, the fumes cause a temporary cooling effect on the Earth's surface. But Hunga Tonga's eruption was different. It didn't produce many fumes, but released a massive amount of water vapor. equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned vast amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its long-term effects on our weather patterns. This is because the only way to measure stratospheric water vapor is with special satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. In fact, the Tonga eruption is the most well-recorded blast of its kind in recent history. Scientists had lots of tools to study it, like satellites that took pictures from space and sensors that listened to the vibrations and movements in the Earth. There was a similar eruption in 1991 at a volcano in the Philippines, but back then, they didn't have as many advanced tools as they do now to study it closely. Experts from different countries looked at satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and of course, what this would mean for the planet and for all of us. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. But Hunga Tonga ended up with just a minimal effect on global average temperatures, at least for now. Let's just hope it won't repeat the story of Mount Tambora volcano in present-day Indonesia. Over 2 centuries ago, in 1815, this bad guy interrupted and caused the year without a summer. In the following year, the winter was unusually cold and wet across Europe and North America. There were also some catastrophic tsunamis, destroying homes that took 10,000 lives and 80,000 more who fell ill in the aftermath. Now, you can't miss an event like Hunga Tonga or Tambora eruption, but some underwater volcanoes are discovered by accident. A passenger on a commercial flight looked out her window above the Pacific Ocean and saw a weirdly colored patch on the water. She thought it could be an oil slick or a floating pumice raft, which is a telltale sign of a recent volcanic eruption. She decided to send a photo of this scene to a geologist. And that's how scientists found one of the largest volcanoes in the world, Havre. It's hiding about 3,000 feet below the surface. In 2012, Havre had a massive eruption that lasted about 90 days. Hot lava poured out of 14 different vents around the volcano's semicircle-shaped opening. Havre is just one of many volcanic systems covered by thousands of feet of water. These volcanoes are the most active on Earth and are part of a giant system called mid-ocean ridges that stretches around the world. This system produces about 75% of all the magma that comes out of Earth's volcanoes each year. It releases over half a cubic mile of lava. When the magma cools down, it forms the edges of new ocean plates, which are like giant puzzle pieces that make up the Earth's crust. A team of scientists studied material left on the ocean floor by volcanic eruptions from the Bronze Age. About 3,600 years ago, a volcano that was partly underwater in the southern Aegean Sea woke up with a bang. This eruption destroyed the island of Santorini and sent massive amounts of ash, rocks, and gases into the air. It left behind thick layers of ash and rock that settled in piles on the ocean floor. Scientists have been studying the ancient Santorini eruption for several years to figure out what happens during such massive ones. Their research helps explain how future volcanic eruptions could affect the weather on our planet. The study also helps scientists understand the strength of the eruptions, how high the eruption columns might go, and the sizes of the waves that form when all that ash and rock settles into terraces on the ocean floor. This information will help predict the dangers of future eruptions. Now, when a volcano erupts, the last place you want to be is inside it. But scientists did it for you. Well, kinda. They produced a smart new imaging technique that uses the best ideas from medical imaging and optical telescopes. Matrix imaging, that's what it's called, makes it easier to understand what's happening underground, even when there aren't many sensors available. These sensors, called geophones, detect and record the movement of seismic waves, which are vibrations that travel through the Earth. By studying these waves, scientists can learn about the distinct types of rocks and how they are arranged beneath the surface. The researchers test their method on a volcano in Guadalupe in the Caribbean Sea. There aren't so many geophones on this site, but the scientists combined the data from multiple geophones thanks to this new tech. They used a special trick called the memory effect to reverse the distortions that happen when seismic waves bounce off different underground materials and figure out what the original signals look like. The researchers could clearly see the structure inside the volcano down to a depth of about 6 miles, with incredibly detailed images in a resolution of over 300 feet. They found out that there are many layers of magma stored underground. These layers are connected to other deep parts of the Earth. Knowing about these layers and how they work could help scientists make better guesses about when a volcano might erupt. If they can do that, they might be able to warn people earlier and keep them safe from dangerous eruptions. Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit. But the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.
In some regions of the Pacific Ocean, ships sink very easily, which is why it is feared by many sailors. Although there are many routes in that area, there are some that few dare to risk because crossing them can mean facing extremely dangerous forces of nature. If you need to travel from Asia to America by ship, the most obvious route would be the shortest and quickest. That is, a nearly straight line under the North Pacific Ocean. But instead, it might be better to avoid crossing this place and opt for longer and more expensive but much safer routes. There is not one, but several reasons. The Pacific is home to some of the most dangerous waters in the world. When we open a world map, we usually see that the Pacific Ocean is kinda divided, which prevents us from realizing how big it is. But in reality, this giant covers almost a third of Earth's surface. It's about 10 times larger than the smallest ocean in the world, the Arctic Ocean. In other words, when crossing it, the chances of being cut off from any landmass are very high. And in cases of emergencies, mechanical failures, or even storms, help might take days or even weeks to arrive. This significantly increases the risk of serious accidents, the possibility of cargo loss, and, in more serious cases, something even worse. Now think about it. A ship journey from Santos, Brazil to Cape Town, South Africa covers a little more than 3,400 miles. To get from Callao, Peru to Shanghai, China, you need to travel around 10,000 miles. Another major problem that prevents sailors from crossing the Pacific is storm systems, whose name already indicates what they contain: unpredictable and therefore dangerous storms. In addition, near the equator, there is a chain of winds called trade winds that directly influence the climate in the tropical region and occasionally cause rain. Trade winds are strong and constant winds that act like a whirlwind that rotates without stopping. And although they are extremely important for nature, as they spread moisture through forests and even influence the formation of deserts, they pose a problem. Their intensity changes depending on the season. In winter, for example, they can be much stronger. And since these winds are responsible for moving the ocean waters, they also create strong sea currents that could make the journey much more dangerous. In 2015, researchers came across a series of extremely strong winter trade winds that caused a surge of short but intense waves in the Pacific Ocean. They observed that those waves began to hit the ship with constant force, as if they were repeatedly punching it. As a result, the hull structure was completely twisted and deformed. And in the end, they confirmed what they had already known. Those waves, caused by winter trade winds, could be a real threat to vessels. And by the way, do you remember that help in the middle of the Pacific can take a considerable amount of time to arrive? So, now there is much more than one reason behind the hostility of the winds. Such a large ocean doesn't have many geographical barriers, such as mountains or large islands. It means that there are no land structures around it that could hold back or slow down the winds and currents. So the trade winds and ocean currents have complete freedom to gain strength and speed. This explains why the Pacific is the scene of powerful storms and giant waves. This is different, for example, from the North Atlantic, where North America, Europe, and Africa help to contain and redirect the atmospheric and maritime systems. It is now very common for scientists to see the bottom of the Pacific Ocean as a giant jigsaw puzzle because it's literally full of moving pieces. It's home to the largest number of tectonic plates on the planet, And one of them, the Pacific Plate, is the largest maritime plate that science has ever identified. This particularity makes the region extremely unstable to earthquakes and volcanic eruptions. Even though the ocean may seem calm at first glance due to its geology, things can change very quickly. This makes it unpredictable and treacherous. For example, in 2022, the cargo ship One Apis was crossing the ocean, 1,600 miles northwest of Hawaii, when it was caught in a torrential storm. As a result, more than 1,800 containers were damaged, falling to the bottom of the sea. Hundreds more collapsed on the deck, turning into a real-life steel domino due to the force of the wind. The captain managed to steer the ship to Japan. The journey lasted about a week, and it was only when they got there that they understood the extent of the loss. But it wasn't just the One Apis. The following year, the ship Maersk Essen lost about 750 containers, while the Maersk Eindhoven lost more than 260. In both cases, the routes were bound for Asia. These three alone have already accounted for much more than the global annual average of containers lost at sea, which is about 1,382 per year. And the most curious thing is that these events happened in winter. Speaking of winter, it was in the winter of 2020 that the Pacific made history. Scientists recorded a 58-foot high wave in the ocean, which is equivalent to the height of a 5 or even 6-story building. In general, a wave is considered giant or extreme when it's more than twice the height of the others around it. This one, however, was almost 3 times bigger than the rest. Now, it's important to remember that despite being rare and scary, these waves are not a tsunami, as they're caused by wind. Tsunamis, on the other hand, usually occur after underwater earthquakes or volcanic eruptions. Another big monster of the Pacific are typhoons, and the 2024 typhoon season confirmed this. One of the highlights was Hurricane Christy. It did not touch the crust, meaning it did not cause direct damage, but we cannot underestimate it. Christy reached Category 5 on the Saffir-Simpson scale, which is the maximum level. A hurricane of this degree is considered catastrophic, so it's no wonder that it was powerful enough to generate huge waves and extremely dangerous rip currents. In addition to this, there was also Super Typhoon Yagi, which hit the Asian continent with such force that it gained the reputation of the most powerful in the last 70 years. When it arrived in Vietnam, it caused around $1.6 billion in damage, destroyed infrastructure in several cities, and left a trail of victims wherever it went. As if that weren't enough, the Pacific is also home to one of the most unstable regions on the planet, the famous Pacific Ring of Fire. It's a huge, crack-shaped area that's home to intense volcanic and seismic activity. It's the most tectonically active place in the world, as the plates of the Earth's crust are constantly moving there. They move apart and collide, or grind against each other, which causes the region to experience earthquakes and volcanic eruptions all the time. Seismographs record some type of tremor there every 5 minutes. This dangerous region is responsible for about 90% of the planet's earthquakes. So, 9 out of 10 tremors occur within this ring, which stretches across the northern Pacific. And the worst part is that it doesn't just affect North America or Asia. In 2023, tremors linked to the Ring of Fire were felt in several Latin American countries, such as Argentina, Chile, Ecuador, and Peru. There was a trail of destruction, and the lives of around 15 people were lost. There's no shortage of reasons for ships to avoid the shortest route across the Pacific and opt for longer routes. As the popular saying goes, prevention is better than cure. There's an old volcano in Bolivia called Uturuncu. It hasn't erupted in about 250,000 years, so you may think that's the end of its story. But recently, it has started to act a little strangely. At the moment, it resembles a zombie that's waking up from a long nap. Uh-oh, is that kind of apocalypse nearing? Uturuncu is a huge mountain in the Andes that's almost 20,000 feet tall. It's called a stratovolcano, which means it's big, steep, and cone-shaped. These kinds of volcanoes are made from layers of lava, ash, and rocks. They can have terrifying, powerful, explosive eruptions because their lava is thick and traps gas inside. Think of it like a shaken-up soda that's ready to burst. Famous ones like Mount Vesuvius are just like Uturuncu. And do you remember about the tragic fate of Pompeii, completely destroyed during the eruption of Mount Vesuvius? Does something similar await Bolivia? Even though Uturuncu has been quiet for a long time, scientists have noticed that it's been letting out gas, rumbling with small earthquakes, and even making the ground around it bulge, kind of like it's stretching. So, people started wondering if it was getting ready to erupt again. Scientists decided to take a closer look at this situation and found out that liquid and gas moving around under the volcano is causing all this activity. It doesn't mean the volcano is definitely going to erupt, but it helps explain why it still seems alive. Let's dive into details. Since the 1990s, scientists have been using satellites and GPS to keep an eye on the ground around the Uturuncu volcano. At one point, they noticed something weird. The ground was rising in the middle and sinking around the edges, kind of like a sombrero hat. The middle part has been slowly going up for at least 50 years, by about 0.4 inches a year. It doesn't sound like a lot, but hold on. This strange shape, along with lots of tiny earthquakes and gas like carbon dioxide coming out of the volcano, made scientists think that there might be a giant blob of magma growing under the mountain. If that were true, it could mean only one scary thing. The volcano could be getting ready to erupt. Uturuncu sits on top of a huge underground pool of magma called the Altiplano Puna magma body. This pool is really big and really deep, stretching under parts of Bolivia, Chile, and Argentina. Scientists thought that magma from the APMB might be rising and collecting near the surface, which could lead to an eruption. But now, after studying more than 1,700 earthquakes and checking the rocks around the volcano, scientists have a new idea. Apparently, it's not magma rising up. Instead, hot fluids and gases are traveling up from the APMB through a narrow path shaped like a chimney. These gases, like steam and CO2, can get trapped under the top of the volcano, while salty water, brine, spreads out sideways into tiny cracks in the rocks. This moving gas and water can make the ground rise and fall and cause small quakes, without any magma getting close to the surface. So the good news is, Uturuncu probably isn't about to erupt. If it did happen, it would cause serious damage to nearby communities and even pose a threat to human lives. Lava flows could reach towns tens of miles away from the volcano, and volcanic ash could even spread across Bolivia, Argentina, and Chile. Luckily, even though the volcano is still alive and rumbling, it's not as dangerous as scientists once thought. This discovery might help scientists figure out if other volcanoes around the world are getting ready to erupt. Now, let's visit Alaska, where according to researchers, Mount Spur might erupt soon. It's letting out strange amounts of volcanic gases from the top and side vent, the very vent that last erupted in 1992. If it erupts again, it could cause problems for airplanes flying nearby and might send ash falling from the sky. The good news is that nobody lives close to it, so people are safe for now. But even though Mount Spur isn't super dangerous, there are other volcanoes around the world that could be really destructive. One of those is Campi Flegrei, a giant volcano system near the city of Naples. Instead of one big mountain, it has 24 craters spread across the area. It last erupted in 1538, but its biggest eruption happened about 40,000 years ago. That explosion covered the whole Mediterranean region in ash and made temperatures drop by up to 16.2 degrees Fahrenheit in Eastern Europe, which led to a very cold volcanic winter. If Campiflegrei erupted again today, it could be very dangerous. It might cover Naples and nearby places in ash, causing earthquakes and landslides, and create air pollution and acid rain. Scientists are keeping an eye on it, especially after a 4.4 magnitude earthquake shook the area in March 2025. But the good news is there's no sign that magma is rising to the surface right now, which means an eruption isn't expected soon. Still, since Italy has a lot of volcanic activity, experts continue to watch it carefully. Mount Vesuvius is also in Italy and is one of the most famous volcanoes in the world. It's known for its huge eruption in 79 CE that buried the Roman cities of Pompeii and Herculaneum. The last time the volcano erupted was in 1944. Today, Vesuvius is even more dangerous because over 3 million people live near it. Around 700,000 people are living illegally right on its slopes, which puts them even more at risk. If the volcano erupts again, it could send rocks and ash flying through the air at nearly 100 miles per hour and cause major destruction, possibly even wiping out Naples. And still, scientists believe a big eruption from Vesuvius probably won't happen for a few hundred more years. But since it's still an active volcano, researchers continue to monitor it. Cumbre Vieja is a volcano on the island of La Palma, which is part of the Canary Islands. It last erupted in 2021. During that eruption, lava poured out of the volcano and flowed all the way to the sea. It destroyed over 3,000 homes, but luckily, thousands of people were safely evacuated, so it wasn't as bad as it could have been. In the past, scientists were worried that a huge eruption could cause the entire western side of the volcano to break off and crash into the ocean. This could create a mega tsunami, sending massive waves hundreds of feet high across the Atlantic Ocean. But more recent studies have shown that this is very unlikely to happen. Mount St. Helens is a volcano in Washington State in the United States. It had a massive eruption in May 1980 that ended the lives of 57 people. That eruption also caused the biggest landslide ever recorded. Hot, pressurized magma exploded from the volcano, shooting ash 15 miles into the sky. Ash covered a huge area, and around 230 square miles of land was destroyed. Mount St. Helens is still active and is expected to erupt again someday, possibly even in our lifetimes. But experts say it's not likely to have another huge sideways blast like the one in 1980, thanks to a deep crater that is now formed at the top. It will change the way the volcano might erupt. Popocatépetl is a big, active volcano in Mexico. It's been slowly erupting on and off since the early 2000s. It's really close to a lot of people, just 40 miles from the Mexico City metropolitan area, which has about 22 million people, and 30 miles from Puebla, which is home to about 6 million inhabitants. If Popocatépetl had a huge eruption, it could cover Mexico City in thick ash as much as 8 inches deep. That ash could block drains, mess up the water, and even stop the electricity from working. Even worse, fast-moving lava and super hot flows, called pyroclastic flows, could rush down the mountain and destroy towns nearby. The volcano was quiet for 50 years, but now it rumbles and shakes pretty often. There have been over a dozen small eruptions, including some as recent as February 2024. Some nearby places got covered in ash, but scientists say this isn't too surprising, and they're keeping a close eye on it.
Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot, even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So, people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangaea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo-Pangaea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangaea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat.
Lake Michigan is one of the largest and most mysterious freshwater lakes in the United States. And now, deep inside it, scientists have stumbled upon something unexplainable. Vast, round craters scattered all across the lake's floor. It all started in 2022. A team of researchers wanted to map the lake's bottom and look for some shipwrecks. At first, they were sure it's going to be just some typical rocky terrain or sandy patches. But what they saw on their sonar screens stopped them cold. Strange, circular shapes that looked almost too perfect to be natural. They were hiding about 500 feet beneath the surface, in places where the water turns dark and impenetrable. Those guys are huge, ranging from 300 to 600 feet wide. They also plunge nearly 40 feet deep. and there are dozens of them, neatly arranged like some footprints. But the team had no idea what these things were. Then, in August 2024, the mystery only deepened. Using a remotely operated vehicle, they got a closer look at these formations. There were about 40 of them. No one had ever seen anything quite like this before in the Great Lakes. What could have created those craters? Could they be ancient? Perhaps remnants of some geological event lost to time? If that's the case, it's weird how long these holes have likely been sitting there, undisturbed. Theories started popping up. One possibility was that they could be sinkholes or dolines. Those are basically holes that suddenly appear in the ground when the surface layer collapses. The rock beneath the surface, often made of limestone, gets slowly dissolved by water over time, creating voids underground. When the surface of those voids can no longer hold its own weight, it caves in, and this forms a hole. Think of it like when you poke a straw through the lid of a drink. Sinkholes can be small dips or huge, spanning up to 2,000 feet. They can happen gradually or all at once. Sometimes they can swallow entire cars or even buildings. And Lake Michigan sits on limestone bedrock. It erodes pretty easily when water flows through it. Sinkholes like these have already been found in Lake Huron, and they look kinda similar. But there are some plot holes, no pun intended, with this theory. For example, it's wild how they all would be so huge. It's also weird and pretty rare for sinkholes to occur in a lake bed. They also kinda resemble a straight pattern. They seem to extend generally southward, forming a loose line, which is pretty weird. If these are sinkholes, then they're definitely not playing the usual geological rules. Though it might be some new, unusual process at play beneath the lake's surface that we haven't discovered yet. There's another theory though: glaciers. Glaciers are wild rivers of ice. They covered much of the Earth during the last ice age, and they're incredibly powerful. While they might move slowly, sometimes only a few inches per day, they have such immense weight that they can reshape entire landscapes over thousands of years. Glaciers can grind and scoop the land beneath them. They're basically like colossal bulldozers. Their weight, combined with the slow but steady movement, grounds down everything beneath them: rocks, soil, even bedrock. This can create deep gouges in the Earth's surface, called glacial troughs. During the last ice age, there were lots of glaciers all over the northern US, including the Great Lakes region. If they moved across what is now Lake Michigan, they could have carved out these deep holes. Glaciers often move in a pretty straight path. As they move, they cause terrain to erode, but the resulting erosion varies based on terrain. Sometimes there are places where the bedrock is softer or fractured, and these places are more easily carved and crushed by the glacier. That could explain why some holes could be bigger and deeper than others. Harder bedrock is less affected. But usually this leads to rounded, crescent-shaped depressions known as chatter marks. Those marks are more like grooves rather than circular, big craters like those in Lake Michigan. Once the glaciers melted, the Great Lakes themselves formed. If the craters were formed by them, they may have filled with water, becoming part of the Michigan Lake. Though this theory is more like a speculation, so we need more evidence. But there's another layer to this mystery. The craters are not just curious geological formations. They actually may hold valuable clues about early life on Earth. Parts of Lake Michigan, especially dark ones, are relatively low in oxygen. It's like a lighter version of deep ocean environments that often have very little of this element. For example, hydrothermal vents deep in the ocean, underwater openings in the Earth's crust with some hot, mineral-rich water that are often very low in oxygen. But some organisms love places like these. For example, opossum shrimp. Teeny tiny shrimp-like creatures that love cold, deep waters. They get their name because they have a pouch to carry their young until they're ready to be on their own. like an opossum. Or deep-water sculpin fish, small bottom-dwelling fish that also enjoys cold lakes. They're well adapted to living in dark waters and usually stay close to the lakebed. And weird organisms like invasive quagga mussels, which kinda look like shells. These are small freshwater mussels that have spread there to the Great Lakes. They attach themselves to hard surfaces and can cause problems for ecosystems by competing with native species for food and space. All these guys could be in Lake Michigan, and even more. There might be microbes or even bacteria that are specially adapted to these harsh conditions, just like it was in Lake Huron. There's only a handful of creatures that could survive deep within these craters, and studying them could give us insight into how life once flourished in Earth's ancient, oxygen-poor oceans. That's because it's in places similar to these where some of the earliest life forms thrived. Early Earth had an atmosphere with little oxygen, although it was much more hot and ancient microbes adapted to this. The Great Lakes, especially Lake Michigan, have always had a bit of a ghostly reputation. Like even this mission was organized to study the shipwrecks. There were about 6,000 of them in the Great Lakes. Many of these wrecks are still sitting on the lake beds, preserved by the cold, fresh waters. And shipwrecks aren't the only strange things tied to the Great Lakes. Over the years, there have been stories of unexplained disappearances. Boats and even planes have vanished without a trace. The lakes, often calm on the surface, can suddenly turn dangerous with unpredictable storms and massive waves, leading to these mysterious events. Not even mentioning all the creepy stuff people noticed there over the centuries, such as ghostly lights above water or bizarre weather patterns like eerie, sudden fogs that seem to appear out of nowhere. In 2007, they even discovered some prehistoric structure that looks like Stonehenge there. Well, it was way smaller, but still. It lay about 40 feet below the surface in the heart of Grand Traverse Bay, and it's speculated to be about 9,000 years old, way older than Stonehenge. Looks like this is a print of those who lived in the area thousands of years ago. These massive stones are arranged in a careful, winding pattern stretching over a mile. They range in size from basketballs to compact cars. But one, in particular, stands out. A boulder 3.5 to 4 feet tall, 5 feet wide. It's etched with the image of a mastodon, a creature that roamed the Earth about 11,000 years ago before it went extinct. It probably sank there during the end of the last ice age we mentioned. This period had reshaped the region. This place is underwater now, but back in the day, it was still dry land. So the stones were probably created by people who lived there, though we're not sure why. Were they used as hunting blinds? Or was it some sort of an ancient calendar? Who knows? Only about 15% of the Great Lakes floors have been explored. Now, scientists are gearing up for a deeper dive into this mystery, both literally and figuratively. They want to analyze the lake beds surrounding the craters, hoping that maybe something in the environment around them might have caused them to appear. They have initiatives like Lakebed 2030. These missions should map the entire underwater landscape. This would help us learn tons of interesting stuff about Lake Michigan and our planet's past. Who knows what other secrets these dark waters hide?
So look at this narrow passage between the north of Morocco and the southern part of the Spanish region. It's called the Strait of Gibraltar. There are only 8 miles between the two continents, but for some reason, there's no bridge, despite people having been dreaming for centuries about connecting these two regions. There are places in the world where a bridge over water stretches for a much greater distance. For example, the Lake Pontchartrain Causeway near New Orleans, Louisiana, goes for 24 miles, which is 3 times the length of the hypothetical bridge between Africa and Europe. That's listed in the Guinness Book of World Records as the longest continuous bridge passing over water. It consists of 2 parallel bridges and connects the urban area of New Orleans with small settlements in the north of Lake Pontchartrain. 9,000 concrete piles hold more than 1,000 decks above the water. This large-scale structure was built in the middle of the 20th century. It only took 14 months from the start of construction to its completion. American engineers created a unique technology for attaching concrete piles to the base of the bridge, and this bridge is still functioning. So, what's the problem with building a shorter bridge to connect Africa and Europe? Let's first find out the value of the 8-mile bridge that could connect two continents and the reason why everyone is talking about it. In fact, the value of such a bridge would be enormous. Diamonds, oil, minerals, Africa is full of valuable materials, and Europe is happy to buy these things. This theoretical bridge could allow people to transport things for trade quickly and comfortably. But now, the exchange of goods between Africa and Europe is only possible thanks to airplanes and cargo ships, and airplanes are extremely expensive because of hefty fuel price tags. In addition, air travel is often delayed because of bad weather. There are long customs procedures and transportation from the airport to the destination. Ships can also be a problem. The narrow area of the Mediterranean Sea, where the two continents are closest to each other, is a dangerous place because of storms and strong currents. The transportation of your diamonds is highly dependent on weather conditions. The second advantage of such a bridge would be the creation of tens of thousands of jobs. People from Europe and Africa would build hotels, ports, parks, and even small towns for each other. The coastal parts of both continents would become a new economic center. And just imagine how much investment those places would attract. Europe and Africa would be much closer than ever before. You could drive from a small Spanish town to a safari park in northern Morocco, buy Moroccan tea, get some argan oil, and go home for the evening. Or you could take a high-speed train across the beautiful Mediterranean Sea. People would open hundreds of restaurants, amusement parks, shopping malls, and a museum next to this bridge. But, unfortunately, it's impossible to build such a bridge, at least at the moment. And here's why. The main problem is the Strait of Gibraltar itself, because of its strong currents and seismic activity. How can you start large-scale construction if, in a couple of days, an underwater earthquake can trigger giant waves and take all the ships underwater? Even if you build a bridge, rapid streams of water that constantly change direction can shake the entire structure and tear the connecting parts of the construction. The bridge over the Strait of Gibraltar must have a strong, sturdy system that will withstand seismic activity. Huge resources are required to create such a complex structure. Despite the dangerous passage between the two continents, it remains one of the busiest points in the world. It's the only place on the planet connecting the Mediterranean Sea and the Atlantic Ocean. About 300 ships pass through this area every day. Not only merchant ships, but also fishing vessels and tourist boats. There are not so many places in the world where you can watch whales coming out of the water. Not only people, but also marine creatures often visit this passage because of the peculiarities of the sea currents. But we'll talk about that later. Another problem is the depth of the strait. In simple words, any bridge over the water is built on long metal piles. Builders and engineers stick piles into the seabed and use them as a holding base for the whole construction. But installing such piles firmly enough is a difficult task because of the uneven seabed. The seabed has a unique geological landscape, irregularities, and different densities of the Earth's rock. There are also reefs, rocks, and pits. Any seabed requires extensive geological studies before piles are installed. However, the bottom of the Strait of Gibraltar is especially difficult because of its depth, almost 3,000 feet. It's one of the deepest straits in the whole world. Just imagine, you'll need the height of 10 Statues of Liberty to reach the surface of the water from the bottom of the strait. What kind of pile should be used there to hold the entire bridge? Most likely, one pile will have to consist of several parts connected into one large metal rod. And don't forget about seismic activity. Let's say you've installed perfectly strong piles, but the next day an earthquake occurs and destroys the entire structure. And a strong current is carrying fortifications all over the Mediterranean Sea. The next problem is probably the most important one. because it concerns marine life. The Strait of Gibraltar has a high salt content. This natural element makes water heavier and makes it descend to the bottom of the deep Mediterranean basin. Then, this salt water pushes up cold water from the seabed into the Atlantic Ocean. These changes in water density, as well as fast currents, create sea vortices and turbulence. It's like a raging cauldron of cold water that raises a lot of nutrients to the surface. The hollows and hills of the Strait of Gibraltar are filled with different substances and sunlight, and this creates ideal conditions for the formation of phytoplankton. Whales, dolphins, and other marine creatures adore this delicacy. That's why you can see about 7 species of whales and dolphins in this place. What might happen to phytoplankton after the start of global construction? Carbon dioxide, crushed rock, tons of dust and ashes, falling building materials – all of this could significantly pollute the environment. Without phytoplankton, many fish would go extinct. Without fish, thousands of fishers wouldn't be able to get food and earn money. But even if the bridge was built, cars and trains would continue to pollute the air and water. This disruption of the delicate balance in this narrow strait can lead to larger-scale environmental disasters. Dolphins and whales may leave to look for food elsewhere, and thus take resources from other marine inhabitants. Like falling dominoes, one problem can follow another. And all this because of one bridge. In 2007, the Spanish Ministry of Environmental Protection introduced speed limits for all ships sailing through the strait in order to not disrupt the delicate balance of nature. At the beginning of the 20th century, a French engineer proposed a project of a bridge, but it was rejected because it was too complicated and costly. People also tried to develop a 23-mile-long tunnel, but this project also faced financial and technical difficulties. People are still dreaming of a bridge over the Strait of Gibraltar. Perhaps, in the future, when we develop cooler technologies, we'll be able to build this thing. Oh, by the way, there hasn't always been water between these two regions. In the distant past, the two continents were connected. The entire Mediterranean Sea is the remains of the Tethys Sea that existed before the era of dinosaurs. Then the African and Indian plates collided with the Eurasian one, and the Tethys Sea completely disappeared. In its place, a land bridge was formed that separated the Mediterranean Sea from the ocean. Without access to water, the sea dried up about 6 million years ago. But then, when the bridge came down, the water began to fill the dried-up pool. For tens of thousands of years, the narrow plate sank lower and lower, and the Mediterranean Sea eventually got its current water levels. It happened 66 million years ago. Hey, it could have been September. A massive asteroid slammed into Earth, bringing along chaos and devastation. The tragic aftermath of the terrifying collision led to the extinction of dinosaurs. Yes, I'm talking about the Chicxulub asteroid that left a massive crater in Mexico and changed life on Earth forever. And now, it turns out it wasn't the only cosmic rock to hit our planet during that time. Scientists have just confirmed there was another asteroid. This second space rock wasn't as big as Chicxulub, but it still packed a punch. It crashed to the ground off the coast of West Africa, smashing into the ocean and leaving a crater called the Nader crater. And tell you what, it wasn't a small splash. The impact was so powerful, it triggered a whole tsunami. It was more than 2,600 feet high, almost as high as the Burj Khalifa, the tallest man-made structure in the world. But how did we come to the conclusion that there was a second impact? Well, this researcher spotted the Nader crater in 2022. Dr. Nicholson was looking for some high-tech scans of the ocean floor when he noticed a massive 5.5-mile-wide depression under almost 1,000 feet of water. Well, he thought it could be an asteroid impact crater, but at the time, the evidence he had wasn't solid. But now, scientists have confirmed that this is the real deal. A second asteroid did hit Earth during the dinosaur extinction era. Now, let's see how they figured all this out. For one thing, there were those super high-resolution 3D seismic images. They allowed researchers to peel back layers of the ocean floor and get a crystal-clear look at the crater. It was like going from a blurry old ultrasound to the kind of 3D scans where you can see every little feature. Their findings confirm that the crater was left by an asteroid, somewhere between 1,500 to 1,640 feet wide. And it didn't just create a hole in the ground. The impact was so intense that it produced a central peak, formed escalating ridges around the crater, and even left a damage zone that stretched out for thousands of miles. Using those super detailed images, the scientists have managed to reconstruct what happened right after the asteroid hit the surface of our planet. First, it slammed into the ocean, creating an initial bowl-shaped crater. As the shockwave spread, the seabed was shaken so violently that it triggered landslides, and the soft sediment surrounding the crater collapsed inward, creating a noticeable brim. As you already know, the impact also triggered a tsunami, and it was so shockingly powerful that its waves didn't just go outward, they actually turned back towards the crater, leaving huge scars on the ocean floor. And this wasn't just one big wave. No, it was a whole series of them, a train of tsunamis smashing everything in their path. Now, this second asteroid impact is a huge deal for scientists. It's a rare opportunity to study a marine impact crater in such incredible detail. There are only about 20 confirmed marine craters in the world, and none of them have been captured with this level of precision before. Plus, this data allows scientists to test new ideas about how craters form in water. You see, unlike craters on land, marine craters are hidden under layers of sediment, which makes them tricky to study. But with this new 3D imaging, we can look at the crater in all its layers. It's like slicing into a cake to see what's inside. Dr. Nicholson and his team are now dreaming of drilling into the crater and recovering samples from deep below the ocean floor. This would allow them to measure the shock pressure during the impact and figure out what happened in the minutes, hours, and days following the collision. Of course, the Chicxulub asteroid is still the star of the show when it comes to the dinosaurs' extinction. This space traveler was giant, somewhere between 6 and 9 miles wide. It hit Earth at a devastating angle, sending vaporized rock and gas into the atmosphere. It caused an impact winter that lasted for 15 years, because all that stuff blocked out the sun and plunged Earth into darkness. Now, probably the most intriguing thing is that some experts think the Nader asteroid might have been a chunk that had broken off from Chicxulub before it hit Earth. It's still just a theory, but if true, it could mean that Earth got hit by a double whammy from space. Now, let's travel back in time to the year 1908 in Siberia. Look around. You see nothing but trees and rivers. And suddenly, a huge object, around 150 to 300 feet in diameter, dashes through the Earth's atmosphere. Is it a comet? An asteroid? Scientists aren't sure. What they do know for sure is that this intruder blew up in the sky over Tunguska, leading to one of the most powerful blasts in recorded history. It completely leveled the forest below, knocking out 80 million trees over an area of around 830 square miles. And that's an area larger than that of cities like Los Angeles or New York. The trees were literally flattened, and their trunks were stripped of branches. They were also arranged in a bizarre radial pattern around the epicenter. But what if this explosion had happened over a city? Every single building would have been destroyed, and countless lives would have been lost. Luckily, this disaster occurred in a super remote part of Siberia. The creepiest thing, though? When scientists finally reached the area years later, they found no impact crater. No wonder it led to even more mystery. The most logical explanation is that when the object went off in the sky, probably around 3 to 6 miles above the ground, it blew up before it could hit the ground. And still, it didn't stop the blast from leveling an entire forest. Fast forward to 2013 and another mind-blowing event. This time over a much more populated area, the city of Chelyabinsk. It was a regular February morning when an asteroid about 60 feet in diameter entered Earth's atmosphere, lighting up the sky. It was moving at a staggering speed of around 43,000 miles per hour. It blew up in midair, about 18 miles above the city. It was a horrific view, but luckily, the asteroid disintegrated high enough in the atmosphere without hitting the ground. If it had touched down, the city would have been in big trouble, because even though there was no direct impact, the explosion still created a shockwave that tore through the atmosphere, hitting the ground with enough force to shatter windows all over the place. The blast damaged around 7,200 buildings, but fortunately, there were no direct fatalities. Still, it was a major wake-up call. This wasn't just some far-off cosmic event like Tunguska. This asteroid exploded over a modern populated area, and the damage was very real. The good news? Scientists are getting better at spotting such objects before they get too close. Space agencies around the world, like NASA, are tracking near-Earth objects to figure out which ones could pose a risk. But as we can see from these two events, sometimes space rocks can still sneak up on us. And while the chances of a major impact are low, the stakes are really high. At the moment, there's one asteroid that NASA is keeping an eye on. It's called Bennu, and it's about the same size as the Nader impactor. Bennu is considered one of the most hazardous objects in near-Earth orbit. According to NASA, there's a small chance it could hit the Earth between the years 2178 and 2290, and the biggest risk date is September 24, 2182. But don't freak out just yet. The odds of the impact are only 1 in 2,700. But still, it's a reminder that Earth is always in the cosmic firing line.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?